G'day everyone, so in this video we are going to be looking at finding the distance of a line. So I've already done a little bit of setup just so the video is a little bit shorter, but find the length of a segment joining -1 and 5 and 3 and -2 correct to 2 decimal places. So there's a couple of ways to do this. First, you can use Pythag, and this is really good if you're a visual kind of person. So you can sketch out your graph like I've done up the top here. Okay, I've done just a rough sketch of my graph, and I've got the points here, and I've just sketched up like a triangle. So hopefully you can see my right angled triangle. Oh, sorry, it's a bit crooked. You can sketch it like Pythag. So what I'm actually going to do here is we'll do this, and then I'll go through the second way, and you'll see we'll get the exact same answer. And it's like doing the same thing, but the second one's just a formula you can plug in. So with this, we just need to work out our side lengths of our triangle. So down the bottom here, we go from -1 to 3 in the x values. So this here is going to be 4. Okay? Then we go from our y values, we need to find how far up this is. So it's sort of like doing your rise over run. We go from 5 to -2. So this here is 7. So now we need to do our Pythag. So hopefully you remember that this is c squared is equal to a squared plus b squared, c squared being the hypotenuse opposite the right angle. So just remember this will be c. So c squared, it doesn't matter what you say a and b, so 7 squared plus 4 squared. This gives us 49 plus 16. So c squared is going to equal 65. But remember, we need to find our side length, not our side length squared. So make sure you do this final step of finding c, which is the square root of 65. And if it asks for an exact value, we'll leave it as that, but it says correct to 2 decimal places. So correct to 2 decimal places, you'll put this into your calculator, and you'd work this out to hopefully be 8.06. would be the distance. Yet again, we aren't given a unit, so make sure you don't put units like centimeters or meters unless it's given. So that's how you do it using Pythag. So I'll just go through filling out our equation here. Just remember, we've got, if you look at the top, x1, y1, x2, y2. So we can actually just do this filling out our equation here. So it is derived just from Pythag, but it's just breaking it down a little bit further. So if you have this equation in here, it's a little bit more straightforward to do. So we've got 3 minus -1 squared plus y2, that's -2, -2 minus 5 squared, and you'll see here how it ends up being pretty much exactly the same, which leaves us with 4 squared, because -3 minus -1, 3 plus 1, and then it's going to be plus, and this is -7 squared, okay? And then this leaves us with the square root of 4 squared plus 7 squared, which is equal to the square root of 65, okay, as well. So hopefully this lets you see how both of these ways comes to the same answer. It just depends on how you want to do it. If you're a bit more of a visual person, then probably this one up the top is the way to do it. If you have both the numbers, you can just plug them into your equation here, and you can just find it out. I prefer this one, okay, because even if you are given a picture like this, you'll have to know the 2 points anyway. So just that's what I prefer, probably this one here, but yet again, you can do it either way. So just remember that, and if you are given, say, how long it is and you need to find one of the other values, you can do this either way as well. It's just about substituting the right values in. So if you're given the distance of it, instead of c squared, that might be an actual value, and you need to work out how far up or down it has gone, okay, or left or right. So hopefully this helps with working out these problems, and good luck.